Hey everyone, in this video we are going to look at recreating the flagship level from the classic arcade game Gorf. In that level there is a mothership that starts on one side of the screen, travels across. When it gets to the other side, it flips around and turns back. When you shoot at the ship, a couple things happen. The outer shell of the ship can be destroyed, so the block that the player shot hits gets destroyed. The inner core, the inside of the ship, there is this enclosure that cannot be destroyed. That if you shoot that, the shot just disappears. It doesn't damage the ship. And within that enclosure is the reactor core. And the only way to shoot the reactor core is, even though the enclosure itself can't be damaged, there's a gap at the bottom where your shot can go up through. So, and if you shoot the reactor core just once, it blows up the mothership, the flagship, and then you beat the level. So the way that this works is, even though the ship looks like a solid object, it's actually a combination or a collection of other objects. And so each piece of the ship that you're damaging is actually its own object. So down here, if you notice, there are 3 images. These are going to be the building blocks. So this is going to be the enclosure that can't be damaged. This is just the regular building block, and then this is just a triangle so that we can have some slanted edges rather than everything be real blocky. And I just want to say, by current standards, there's nothing impressive about the way the flagship looks now. We're going to recreate something that looks similar to it, at least in basic, broad strokes. But once you know how this technique works, you can apply this to other games. So let's begin. Now, if you click on Game Object and you go to 2D Object and you click on Sprite, if you notice here in the Sprite Renderer, there's no sprite selected. As you can see, you don't see anything. But as a quick time saver, if you click on the asset that you want to use and do the same thing, Game Object, 2D Object, Sprite, it clearly has selected that asset. Slight time saver. Okay, so a few things. We want bullets to be able to collide with the edges, the outside, and not have anything happen. But we want things to pass through the bottom. So the way that works is that uses a collider. The collider does just as the name suggests, it checks for collisions. So what we're going to do is we're going to add a collider to this, but we're going to add a special type. So with the object selected, we're going to click on Add Component. We're going to click on Physics 2D. Make sure you use the 2D version. And we are going to use Polygon Collider. So by default, it just makes this rectangle, which isn't what we want. If you click anywhere in the line, oops, sorry, got to click on the Edit Collider. See how there's a dot? That moving dot, if you click, you've just created a dot there. And now we click again, and we drag that up. Click again, drag up. Click again, drag that down. And so now if we hide the sprite, you can see it basically matches, not 100%, but close enough. Good enough for this particular exercise. So what happens is, only where the collider, the polygon collider, is drawn will detect a collision with this object. So there's no line here, which means a shot can travel up into the reactor core. So just like that, we have our reactor core. Well, at least the enclosure. And let's call this, we'll just call this metal. Naming really doesn't matter. And as I mentioned, you want to use white images, and the reason for it is you can change this to whatever color you want. So we're just going to click on Color, make it like a gray. Now, the rest of this is basically just going to be able to, we're going to create a default block and then just copy it over and over and over again. And like I said, once I've placed a few blocks, then I'll jump ahead because I don't want to waste anyone's time. So again, we'll go to, let's select the box this time, Game Object, 2D object, sprite, there's our box. I'm actually going to push this one off to the side just so we don't use it. We're going to copy it, but I want to keep a master around. And we'll call this shell because it'll be the outer shell, or you could call it hull, whatever. Does not matter. And so what you do is you just start copying and pasting these. Now, you certainly can look at the values in the transform component to calculate exactly where you want to place these. But for this type of game, you can just eyeball it. And you got to remember, we're zoomed in super close. So any little things that aren't lined up really won't show up. As long as there isn't anything egregious, as long as there isn't a gap. And when we run it, we'll see any gaps and can adjust accordingly. Now, I mentioned that the outer shell for the most part is yellow. So what we're going to do is we're going to take this one, we're going to click on color, and we make it yellow. And now we're just going to copy that one. And like, for instance, there's like a fin down here. So let's actually copy these two together. And then we'll, actually, before we do anything else, we said the fin is blue. So we're going to click on color, make them blue. And now we copy those. What we're going to do is we're going to slide these two over. And then we're going to put a diagonal here. So we don't actually have to create a new object. What we could do is take one of the current ones, and we just take the angle and replace that. As you can see, it's rotated the wrong way, so you can just rotate this either by hand, but in this case, you're probably going to want to put in the right angle, or I should say the correct angle, since right angle has a specific meaning, and this one would be -90. And again, it's just lining it up. The reason why the edge doesn't quite line up is because, unlike the block, the edge, I believe, had anti-aliasing in the paint program I was using. So you would want to be mindful of that as far as whether or not you're using anti-aliasing in your paint program. And now what we can do, we then can take these three, and then we can extend out that fin. And we could take this block. Now, it doesn't fit nice and neat, but that's okay. Even though you're starting with a standard block size, you can indeed scale these. It's not like Minecraft where everything has to be 1 by 1 by 1 to fit nice and neat. You can just scale these if you want. So, you can make this say 1.2, 3. There we go. Okay, so I think I'm just about ready to jump ahead because at this point it's just rinse and repeat. We will do a couple more. Okay. What we can do is we can now take this whole stack, copy and paste it. slide it over here. And you can have the front of the ship extend out, because there's just like kind of like a nose to it. And we can take one of the slanted ones, move over here. And this time we're going to rotate this, actually 0. The default rotation is fine. It's like just the bridge or whatever. And again, change the color. A little bit trickier. Actually, to get the color exactly right, let's just copy one of these and replace it. It really just helps demonstrate the interchangeability of these. There we go. So I'm just going to splice ahead because, like I said, I don't want to waste your time. You can do this on your own, but looks like we might have some gaps. Don't see them now, but when they're in movement, gaps will become more obvious, and so we just tweak accordingly. So there are definitely a few more things I need to show you, but like I said, I'm just going to finish drawing the ship offline, and then we'll get to those things. Okay, so I'll be back in a few minutes. And we're back. So it's nothing really spectacular to look at, but again, the original was fairly basic too. So to make this work, there's a couple things we need to do. One of them we could have already done, but it's an easy fix. Each one of these individual blocks needs a collider. That way it can detect whether or not the player shot has collided with it. I neglected to do that, but you can do this in bulk. So we already added a collider to the shell, and I said that, to the enclosure, not the shell. And we already said that we're going to keep one shell block by itself that we're not going to use. So select everything else. So that's just click, shift, click. Go to Add Component, Physics 2D, but this time I'm going to do Box Collider because we don't need a custom shape. So we do Box Collider. And now watch what happens when we zoom in on one of these. So I'm going to move it out, and I'm going to do Edit. You can see the green dots perfectly surrounding the shape. So each single block has its own collider now. So you could have done that ahead of time, but again, it's easy enough to do it here. Now the triangles will also have, you can see the green line of the box collider, but it's not like there's any shots coming down from above, so that extra collision area really should not be a problem. Likewise, it'd be collision area there. So usually you want the collision to be fairly precise, but again, since there's no shots coming down from above, should not have any kind of negative impact. Now, the next thing that we need is we need a script that checks for a collision with the enemy, with the player bullet. So what we're going to do, we're going to have to code for something that really isn't here yet. So we're going to right-click, create C#, and we'll call this shell con. What we're going to do, we're going to open this up. Where you see this double slash, that tells you that this is a remark statement. It's not executed, it's just documentation. This is stating that what happens in the start section happens only once when the object is instantiated. This says that everything that happens in the update section happens once per frame. we're not actually going to check for, we're not going to put anything in either of those yet. So outside of start, outside of update, but within the public class, we are going to write on trigger enter 2D. Everything else pre-populated because I'm using Microsoft Visual Studio. And I'm going to change this. See how this says collision? I don't like the fact that it says collision because this is actually referencing an object. It's referencing what's been collided with. So you'll see a lot of programmers do that. They'll change it to other. It's self-documentation where it's saying this is the other object in the collision. And so it makes coding this fairly easy. So if other dot tag. We haven't talked about tags yet. We're about to. A tag is basically a way of identifying an object. And the reason why you'd use a tag is, say you have multiple different objects, but they all behave the same way. You can give all those objects the same tag, and then decisions can be made based on the tag. And you'll see in a few minutes how this works out. So we don't actually have the tag yet. So if other dot tag equals, we'll use the tag shot, so the player shot. So what happens is when we create the player's bullets later, we'll give them the tag of shot. So that's what I'm saying. We're kind of having to do some things a little bit out of order here, and you'll see why. And then we'll just say destroy game object. So that's the core gameplay that I was just talking about, and that is when the player shot hits the outer hole, that piece of the outer hole gets destroyed. So just like that, we've put that into place. Now that also needs to be applied to everything except the enclosure and our default shell that we're keeping. And then you just apply the script. So again, we could have done those two things before we assembled, but it's easy enough to fix it after the fact. So you just click. You can see this has the shell, the box collider, shell, box collider, shell. So, okay. So now we need the ship to move. And yes, I will eventually add the reactor core. That will just be like a quick particle system. I don't want to get too deep into a particle system at the moment. Those are the most complex objects. So I don't want to get distracted with something that's basically just a visual flourish. I mean, if you want, you could just take some of these blocks, make them red, put them in there, and call it a day. But we'll get to that. So anyways, now what we need is the ship to move. So how do you move every single one of these pieces in tandem? The answer is you don't. Technically, you don't. What you do is you take an object, attach a script to that object that makes that object move, and then you make these objects a child. You make all these objects that are on the screen children to that new object. So in other words, you're creating a parent object. The parent object is the only object that you're making move, and all the children inherit that movement. So let's take a look how that would look. So let's just go to game object, and we'll go to create empty, and we'll just leave it as that name for the moment because it doesn't matter. So again, we're going to select everything. This time we do select metal though. So the only thing that we're not selecting is the camera, the shell, and the object we created. Just left click, drag it onto that, and see how they're all indented? That tells you they're all children of this. So just going to do a quick demonstration. So if I move just the parent, everything else moves as well. Okay. So what we're going to do is we're going to add a rigid body 2D to the game object, which allows for the application of velocity. And then we're going to add a script that controls it. So, very important, just that parent object is selected. Add component, physics 2D, rigid body 2D. No gravity, or else the ship would fall from space. As an aside note, if you want to do that for like dramatic purposes, like when the ship gets destroyed and you want it to fall out of space, you could then apply gravity. You can do that via a script if you want. Okay, so right click, create C#, and we'll call this flagship. And now what we do is we take the game object, attach flagship, and then we open up flagship. So flag should open up. Delete these again, exactly the same thing. They're just remark statements. And now for this, we're going to put this into the start section. Why? Because in the start section, we said this occurs when the object is instantiated. So we want the velocity to be applied as soon as the object is created. So get component, rigid body, and 2D. Make sure you're choosing the 2D or this will not work. Sorry if I keep saying that, but it's so easy to choose. You have to match the code with the component. So if it's the 3D version, then you need to do the 3D coding. If it's the 2D version, you need to do the 2D coding. And this is a vector 2 only because we are in the 2D environment. X will be, say, +1, and it's not moving on the y-axis. And what this will also do, when it's in movement, it's easier to see if there's gaps. That'll let us know if there's any gaps. I probably won't fix them because, again, it's just tweaking either the location or the scale. So, and did I apply? Yes, I put the script there. Has the rigid body. That should work. Let's just slide this over a bit. So actually, it looks like that is the only line. So we did pretty good, actually, a little bit there too. So again, you just clean those up by a little bit of scaling. I believe I said it was, yeah, you can actually see the line right there. So what we could do is we could scale this one like, made it just slightly wider. So the other one was here. Okay. So now what we're going to do, I'm not going to write it again since we're just clearing up the lines. What we're now going to do is when the ship reaches the edge, it turns around. So it doesn't look really great because you've got this big ship that instantly rotates, but that's how the original game works. So we'll just replicate that. So basically what we're going to do is we're going to have a collider here, a collider here. When it hits the collider, the whole image gets flipped, which is actually really easy to do, and the velocity changes. So what we're going to do, game object, create empty, and we'll take this object and we'll put it over here. And this will be add component. And we will do physics 2D. And we will do box collider. And we'll edit, and we'll just stretch that out to make sure this strikes it. We're going to have to put a collider on the parent so it detects the collision. And now we'll just copy and paste this, put it over here. And what we'll do is we'll probably also give these two barriers, these two border, give them their own tags as well. So we'll go back to our parent, just the parent is selected. We'll add physics 2D, box collider, so it gets its own box collider. Oops. One thing I could have done differently, when I created the game object, I did not align the game object with this, so the game object is actually like lower. That's why the collider box showed up down here, but it shouldn't be a problem because it's only moving horizontally, and the box collider determines where the collision occurs. So even though the object is technically down here, the collision is up here. So the collision does not have to match where the object itself is. But I did just want to mention that so you know why the box collider is down there, because technically the object is down there. So we now have our collider in front of the ship, and what we're going to do, we will add some tags. So we said that we're going to use the tag shot. Let's put that one in there so we don't forget. Save. Click on the plus sign, and we'll call this R border. All lowercase, just that way you're not wondering about which letters are uppercase. So I recommend sticking with all of one when you're doing actual values like this that you're checking. And then L border. Okay. Now that doesn't actually set the tags. You now have to come back. Oops, sorry, I didn't mean to zoom out like that. So you select the object. You see how it's not actually tagged? So when you add tag, you're not adding the tag to the object, you're creating the tag. So this one will be right border, and this one will be left border. And now what we do is we just check for that collision. Now I think, let's go ahead and make this a trigger on the ship. And these shouldn't matter. We'll go ahead and make them triggers. That way there's no solid collisions. There's overlapping collisions, but not solid collisions. And now what we do, we're back to the flagship, and now the flagship is going to check for that. So, on trigger, enter again, 2D. And again, the rest of this stuff auto-populates because it's Microsoft Visual Studio. If, just like last time, change this to other so it makes it more clear what's going on. So if other dot tag equals, and we said R border, in quotes, squiggly brackets. So if the tag of the object that's being collided with is R border, then we want something to happen. Well, I like being lazy, so we're going to copy this, paste this here, but it's going to become a -1 horizontal velocity. And what we're also going to do is we want the ship to flip around. There's actually an incredibly simple way to do this. So transform. So you know how when we were looking at an option at the the components of an object, there's this scale. Well, you can actually make this into the negatives, and by creating negatives, it flips the object. And again, you're doing this just to the parent because the children will inherit it. Although rather than scale, you say local scale. Why it doesn't exactly match, who knows? It's Unity. And again, could do vector 3, but we don't think there should be a problem with vector 2. Because again, the z-axis is not being considered, so technically should not be an issue. And it will also be -1, but the y-axis is staying the same. The y scale. It's a coincidence that these are -1. It's not that these necessarily have to match. It's just that I'm moving to the left, which is a negative velocity, and I happen to want to flip it. And now let's just rinse and repeat. We take this, We copy, we paste, and now we change it. If it's left border, then the velocity is +1, and the local scale is +1. Again, it's just a coincidence. It works out nice, makes it a little bit easier on the eyes. But now, if I didn't forget anything, it should now flip. It's not going to look great because what happens is when it collides here, it flips, but it flips at the front point, which means most of the ship is going to go off the screen. So we may come up with something that also changes the position. Looks nice and clean, not seeing any gaps. It flips around. Actually, that didn't look so bad. Usually flips off the screen, so pretty happy with the way that looked. Actually, that looked great. Now, one of the things that we had to do is when we checked, you know how I put the script on that checked for the name of the object that the blocks are colliding with? So for ShellCon, if I hadn't done this, when the blocks collided with the border, they would have been destroyed. So we did that in anticipation. And a brief splice there. Okay, so let's work on the reactor core now. So that's just going to be a particle system. So let's go to Game Object, and we're going to go to Effect, and we'll go to Particle System. And let's do a couple of things. Let's rotate this towards the screen. And so we'll just change that to -180. And now we'll shrink the particles. So start size, we'll make this like 0.1. We need to shrink, we need to reduce how long they last. Let's change that to 1. We need to slow them down. Let's change that to 1. All right, we're starting to get there. There's not nearly enough of them, and they are spawning from too large of an area. We need to reduce the spawn area. That's better. Let me reduce it a little bit more. And we can have them slow down a bit more. And it's important to note that as you change one aspect, you might have to change another to accommodate. So let's also change the color. And now let's increase the emission. Let's make this like 200. And you can do other things, like you can have the size change. Over a lifetime, you can make them smaller. That way they don't just suddenly disappear. But again, this is what I mentioned earlier. I don't want to do a deep dive on particle systems. There's plenty of other videos. I have a whole bunch about those as well. So let's just decrease their lifetime just a tiny bit more. Actually, let's decrease their speed. Either one will keep them from going out as far. So if their start speed is, say, 0.7, there we go. Okay, so we just need to link it. So we're just going to take the particle system, link it to the game object, the parent. There we go. So it might look a little weird having a particle system with the kind of bulky graphics, but again, now that you know how this works, you can certainly make it look better than this. I do want to mention that this will only scale out just so well that it will having this many object with this many colliders isn't an issue, but the more and more objects and the more colliders, it will eventually have a performance impact. You probably could do 3 or 4 times the amount and still be okay. But if you go much bigger than that, depending on what system it is running on, you might start having performance issues. And again, that kind of statement does not age very well because obviously with every year, computers become more powerful. So I do want to mention that this method doesn't scale out that well, that eventually there will be a performance impact. But in the basic ballpark of this, like I said, 2-3 times wouldn't be a problem. But if you're trying to make like a whole world or something like this, then you would need to come up with a better plan. Okay, so let's add a collider to the particle system. So add component. And this can just be a box collider. So physics 2D, box collider. And just to reinforce, this is a collider for the object as a whole and not for the individual particles. That's an entirely different kettle of fish. So if you're trying to make individual particles collide, that's something else entirely different as far as how you would do that. So now we just need the script to detect a hit from shot. So what we'll do for that, we'll create another script. So right click, create, and we'll do C# and we'll call this reactor. Click on our particle system, drag and drop reactor, and then open reactor. Again, get rid of the remark statements. They're not executed. They're for internal documentation only. And we're just simply going to look for a collision again. Oh, that reminds me. Sorry for jumping around. We added the box collider, but we didn't make it a trigger. So again, outside of start, outside of update, but within the public class, on trigger entered. Ooh, let's try that again. I think I hit the end key. On trigger enter 2D. If. And again, I forgot to change that. Sorry, not trying to rush through. So if other dot tag equals, and we use shot. Now, since this isn't a complete game, what you do here would be very different. You'd probably actually load a new scene, do like a high score, something like that. You know, like do like a tally screen where it says, here's your points, here's your bonus. And then you load, since this isn't part of a larger program, can't do any of that. But just so you know that it's working, we'll just do debug.log, and that it will give a message, you win. Okay, so can't really test that yet. So the last thing that we need to put into place will be the player as well as the controller for the player. So we're going to create a little player here. The character can move around and he can shoot the bullets, and then that's where we can test everything. Let's put that in one more video because this video has already gotten kind of long. So I'll do just one more video to do that, and then I think we'll be done with this particular project. I hope that's been helpful. If there's anything else you want to see added to this project, let me know, because like I said, I'm thinking of doing just one more video because I'm not looking to recreate all of Gorf. I just wanted to demonstrate how you could have this destructible ship. Okay, so hopefully this has been helpful, and I'll see you in the next video.